We often imagine an unmanned factory as a simple image. The lights go out, people leave, and machines take over everything. But the moment that truly changes the direction of engineering comes when a system becomes so complex that having humans remain in the middle only slows it down. The 10 projects that follow are not about whether people are present, but about something else entirely, whether the system still allows humans to exist within it at all. Number 10. Amazon Robotics Fulfillment Center. If demand were stable, warehouses would not be difficult to run. The problem Amazon faces has never been stability. Every day brings hundreds of millions of possible product combinations, highly random order paths, no fixed storage locations, no fixed flows, and no predictable peaks. Under these conditions, traditional warehouses collapse in efficiency, not because people are slow, but because the space itself stops making sense. Amazon's solution was not to make people pick faster, but to overturn a long-assumed premise: why must people go to the goods? Instead, the shelves move. The warehouse floor becomes a real-time computational network. Thousands of robots continuously reshuffle space, turning a building designed for predictable flow into an industrial system that can absorb extreme uncertainty. People still exist here, but they no longer decide routes, rhythm, or priorities. Those judgments belong to the system. Efficiency is no longer defined by experience or distance walked, but by how algorithms can recompute the entire building in seconds. You might argue that if people are still present, this is not truly unmanned, and that objection is fair. Amazon was never chasing emptiness. It was chasing independence from human real-time judgment under chaotic demand. It is not the most extreme unmanned system, but it was the first to clearly reveal a trend. Once scale and uncertainty pass a threshold, humans must step out of the rhythm. From here on, that retreat shifts from a choice to a necessity. Number 9. Ocado Automated Customer Fulfillment Center. If Amazon is managing chaos, Ocado faces the opposite. Its orders are highly predictable, but the time windows are brutally tight. Every order must arrive on schedule. Every item has a shelf life, temperature constraints, and packing sequence. Errors are not delays, they are waste. Under these conditions, human operation exposes a fatal weakness. Consistency cannot be guaranteed. Ocado's goal was never speed, but absolute control. What you see is not aisles and zones, but a vast algorithm-ruled grid. Robots do not roam freely. They are locked into tracks. Every acceleration, deceleration, crossing, and avoidance is pre-computed. Unmanned here does not mean removing people, but forbidding them from interfering with the rhythm. Once human judgment enters the loop, determinism collapses. This design is rigid, and deliberately so. Ocado trades flexibility for stability, generality for precision. Unlike Amazon, it cannot endlessly reconfigure space. If demand models shift, costs surge. Ocado does not show the endpoint of unmanned systems, but the extreme of another path. When certainty is pushed to its limit, humans become the largest source of uncertainty. From this point on, unmanned is no longer just about efficiency, but about engineering trade-offs. Number 8. BMW Leipzig plant. In many imaginations, automotive factories should be the closest thing to fully unmanned systems. Welding, painting, and transport are highly automated, with rigid takt times. If even here full unmanning fails, the concept itself seems fragile. Yet BMW Leipzig proves the opposite. Its challenge is not automation, but change. A single line builds combustion, hybrid, and electric vehicles simultaneously. Model switches are frequent. Configurations explode in number. In this environment, the goal is not to remove people, but to preserve flexibility. Welding and painting can be highly automated, but in final assembly, human presence is a deliberate choice, not a technical lag. Judgment here comes not from algorithms, but from immediate handling of subtle variation. This is why even the most advanced car plants only achieve unmanned in isolated segments. So why does it belong on this list? Because of its boundaries. BMW Leipzig draws a clear line between where humans are redundant and where they remain indispensable. This is not technological weakness, but engineering rationality. It reminds us that when products themselves must change, unmanned is not always progress. Next, the story shifts. Not because variation is too high, but because variation has been eliminated entirely. Number 7. Foxconn Lights Out Factory. The term lights out factory carries a powerful image. Lights off, people gone, machines running alone. Foxconn is its most cited example, yet inside these factories, the truth is less comfortable. The lights may be off, but people have not vanished. Lights out exists in specific times, processes, and lines, not entire factories. Electronics manufacturing is not limited by repetition, but by yield control at massive scale. Components are tiny, cycles are fast, and microscopic deviations amplify instantly. Foxconn's solution is not full removal, but assigning machines to stability and calling humans only for exceptions. Lights out is a state, not a permanent structure. This is not mere branding. Foxconn reframed overnight continuous operation as an engineering goal. Machines do not need rest. People should not have to follow the rhythm through the night. At extreme scale, full-time human presence becomes a system burden. Foxconn did not prove lights-out factories exist in purity. It proved something more realistic. When volume reaches its limit, humans belong only where problems occur. Number 6. Tesla Gigafactory, Berlin. By reputation, Tesla should rank higher. Automation, robotics, radical efficiency, it defines the future factory image. Yet Berlin stands as a warning. Early plans pushed automation aggressively toward full unmanning. The result was not efficiency, but frequent takt disruptions and runaway debugging costs. The issue was not technical skill, but product complexity. A car is not a standardized unit. It is tens of thousands of parts, multiple process paths, and constantly evolving designs. When change frequency crosses a threshold, systems cannot pre-model every exception. Humans then stop being obstacles and become buffers. Berlin ultimately rebalanced roles. Machines handle consistency, humans absorb unpredictability. This may sound like retreat, but it is a sober correction. Tesla did not prove that unmanned factories are superior. It proved that beyond a certain complexity, full automation can reduce stability. Number 5. CATL, Ningde Battery Cell Factory. On a battery cell line, whether humans participate is not a value judgment, but a risk calculation. Consistency and cleanliness requirements are so extreme that even invisible dust or slight humidity shifts affect yield and lifespan. In such environments, humans are not quality enhancers, but instability sources. CATL designed its factories on a simple premise. People should not stand by the line. Processes are sealed in controlled environments with continuous operation and minimal fluctuation. Machines do not adapt to humans. Humans adapt to machine boundaries. Lights out is irrelevant here. What matters is whether anything breaks environmental closure. This marks a turning point. Unmanned is no longer optimization or cost control, but a prerequisite for process viability. From here on, scale pushes this logic further, until humans can no longer participate at all. Number 4. Alibaba Cainiao Smart Logistics Hub. Clean systems can isolate people, but Cainiao faces something else. Scale itself has broken loose. Shopping festivals generate traffic surges by multiples and orders of magnitude. Parcels arrive in waves, not streams. Hiring more people does not help, because humans understand processes, not entire system states simultaneously. Cainiao shifted focus from maximizing automation on single lines to real-time orchestration, where parcels go, which paths they take, and who takes over next. The hardware is visible: sorters, high bay storage, AGVs, conveyors. But efficiency is determined by millisecond-level flow reorganization. Humans remain, but only as monitors, maintainers, and fail-safes. Not because they lack value, but because at this scale they cannot participate in real-time decisions. This is software forced by scale. Once throughput crosses a threshold, any system requiring human instant judgment collapses before hardware does. From here, the top three no longer ask whether humans should be involved, but whether systems still allow proximity. Number 3. Siemens Amberg Electronics Plant. If there is a factory engineers openly acknowledge as truly unmanned, Amberg is unavoidable. Producing industrial control equipment, its reliability requirements exceed consumer electronics. Reliability cannot be patched by humans. A single error may surface years later at immense cost. Siemens made a radical move. It removed production decisions from human hands entirely. Design, process, testing, and quality feedback are sealed into a closed loop. Data does not assist judgment, it replaces it. Humans do not stand on the line or intervene intact. Their work happens outside the system: modeling, optimization, verification. This isolation sustains near-perfect yield over time. Amberg's unmanned nature is not technological showmanship, but acceptance of a hard truth. Humans are unreliable for long-term stability. Number 2. Port of Rotterdam Automated Container Terminal. Within factory scale, one can still debate human participation. At Rotterdam, the question collapses. This is not a line, but continuous global logistics. Ships berth, containers stack, transfer, load, and depart without pause. The rhythm is 24/7 and non-interruptible. At this scale, on-site human operation becomes a safety hazard, not an efficiency issue. Unmanning begins with spatial design. Automated cranes, unmanned vehicles, sealed yards, centimeter-level positioning isolate humans entirely. People exist only in control rooms, and even there, they supervise rather than command. The terminal solves a deeper problem. In continuous global systems, humans cannot be real-time participants. Any node requiring human instant judgment becomes a risk source. This is why Rotterdam ranks second. It represents a point of no return. Once scale reaches this level, the question is no longer whether to remove humans, but whether humans can still exist at all. Number 1. Shanghai Yangshan Automated Container Terminal. Yangshan does not answer whether machines can replace humans. It asks something more extreme. If a system must operate non-stop, year-round, with any pause causing cascading failures, can humans exist inside it at all? This system exceeds a single port, linking transoceanic routes, inland rail, and the logistics rhythm of the Yangtze River Delta. Time windows are non-negotiable. Missed schedules ripple through everything. Any element dependent on human instant response becomes instability. Yangshan's design made a clear decision from the start. Humans do not enter the operating zone. Cranes, rail-mounted gantries, and unmanned vehicles coordinate within a sealed, continuous space. Tasks are assigned, errors corrected, rhythm maintained autonomously. Humans remain only in distant control centers, confirming system health rather than operating it. This is why Yangshan ranks first. It is not the darkest or the most robotic, but the only system where reintroducing humans would degrade the engineering itself. Here, unmanned is no longer a goal, but an irreversible prerequisite. If you followed this ranking, a shift should be clear. It does not begin with whether people are present, nor end with how many robots exist. It traces a moving boundary, from humans stepping out of rhythm to isolation outside systems, to systems that no longer permit human proximity. This is not human obsolescence. It is the arrival of engineering domains that no longer suit direct human participation. Thank you for watching. See you next time.